Hi, I'm Dave Robinson, and welcome to another one of my screencasts where I'll be using R and RStudio to analyze data that I have never seen before. As usual, this data comes from the Tidy Tuesday project, which is a great project run by the R for Data Science online learning community that every week releases a new data set for people to analyze. So let's see what we have this week. All I know about it is it's a Halloween themed data set and it's horror movies. That's cool. So what I think is cool about this data is I started doing these screencasts almost exactly a year ago, and the second data set that I worked on back then was also about horror movies. And yes, last year for Halloween we focused on horror movie profit. Feel free to take a peek at that data as well. Maybe I'll join in. Oh, that's interesting. Film and locations budget. Okay, so maybe after once we get to feel for this data set, we'll try joining in last year's data as well, so we can bring in budget. But I'm not sure we will. Let's see what we have from the data for starters. Horror movies. I'm not sure I'd call myself a horror movie fan. I like plenty of horror movies. And I actually am looking for some to. I like watching them in October, so I was looking for some to watch this week while Halloween is coming up. So I might just learn of something I should watch from this screencast. Still like to see Us. I didn't see Us yet. That's a movie that came out a horror movie that came out in March, and I've been looking forward to checking out. All right. Problem is, I don't really have anyone. Most of my friends don't like horror movies. My wife doesn't. So there's only a few friends that I go to horror movies with. All right. So here we have 3,328 horror movies, as well as movie ratings for each of them. So what is the best movie rating review of all best reviewed movie of all time? One thing is we don't have here. We don't know what the we don't know how many ratings each of these got, so it can be a little bit, it could be a little hard to trust these numbers. It could come from, some of these could come from just a handful of movie ratings. Here's one that came out in October 2017, and it looks like Bone Hill Road has really high rating on IMDb. Have I heard of any of these movies? I'm not sure I've heard of a single one of these highly rated movies, horror movies. Man, I don't know the first thing about. Some of these have to be made up. Oh, all right. All right, it looks also to me like a lot of them are recent. I'm looking here at release date. Ooh, release date is going to be a little bit difficult to parse, which is kind of fun. Oh no, but I can actually get the year out of the title. So I'm actually, notice this, they're sometimes in different formats, some say 2016, just a year. What I'm gonna actually do, some of them don't look like they're very accurate. Like here's, this one says the movie's from 2015, but has a release date in 2017. Which of them should I trust? So it's it looks like it was released in 2015, but it was maybe it was released in the United States or worldwide in 2017. In Canada, it was released in 2017, even though it is a Filipino-Japanese action horror movie. Okay, I'm not going to pay attention to the release dates. I'm going to be paying attention to the title year. Okay, so what I'm going to do is add in here extract. If you haven't seen extract, it's a wonderful function in tidyr that I say extract from the title anything of the pattern digit, 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 digit surrounded by parentheses. And then to say, I need to tell it that it's and put that in year. I need to say, there's a little funny, that I want to capture what's in the parentheses, then it's surrounded by parentheses. I need to also say remove equals false. I don't want to remove the title. I want to create the year next to it. This shows year popping up as a character vector, a string, which is not actually the case. It should be a number. Convert equals true will automatically discover that the year is a number, keep it like 2017. Last thing I'm going to do is, just in case there's a year elsewhere in the data, in the string, I'm going to say this regular expression means must be parentheses, year, and end the string. Were there any where we were missing the year? Filter is NA year. Only one. What was the title of that one? American Exorcist, it was missing a year. Okay. What's the distribution of years? The distribution, I usually do a histogram. Yeah, we see like very few that came out before about 2005 maybe. So I'm going to throw in just so we can see it a bit better. If we want to look at have horror movies changed over time, we're definitely going to have no success looking before about 2011, 2012. Most of the ones we have ratings on are in the last 5 years or so. Okay, so that's something we now know. I'm not even going to keep that data. I'm just going to keep that in mind that most of the movies are since 2012 or so. And I'm going to save this as horror movies processed. I'm actually going to name this horror movies raw, name this horror movies. Then I can just use horror movies whenever I like and keep the processing code up in here. Yes. All right. What time I started out? Okay. All right. So okay. So let's take a look at these horror movies. What do I have? I have what genres? There's multiple genres, aren't there? Horror and horror thriller and comedy horror and horror mystery thriller, and so on. Are all of these horror? I'm going to guess so, just based looking at some of these. I think that's what we filtered it down by. Okay, I'm definitely going to return to that and do some unnesting. But here we go. What else do I have? I have, it's interesting. I have a plot, which is I have a language. Most of them are English, so I don't think I can do all that much with language just because such a vast majority are English, and then, well, there's a number in a couple other languages. Okay, good to know. And that budget, counting a budget doesn't make much sense, but it's one way to look at values and say, okay, it generally is like, it generally has monetary amounts. The way that we can process that out is called parse number. So I'm going to say budget equals parse number from budget. And now I can plot. It's a lot of missing budgets. I'm going to quickly do a thing where I say, all right, of the ones filter is NA budget 2. What I'm doing is a quick trick where I want to see what are the budgets we can't parse. Is it only ones that are missing? Yes, that's good news. Either we're missing a budget or we're able to parse it. Okay. And in the meantime, we're going to look at our distribution of. So 2/3 of our budgets are missing, and as usual with anything with money, we're going to need. I'm also going to throw the labels on a dollar format. And anything with money will have kind of a log normal scale. That is one that exists on many logarithmic like kind of magnitudes. 100,000, 100,000, 100 million. What a difference between a movie with $100 budget and $100 million budget. Okay, so almost anything we do with budget is going to be on an x-axis. Okay, on a log axis, I mean. This brings me to my first question. One of my questions is, do better movies, do higher budget movies end up higher rated? I'm going to make a prediction. My prediction is yes, but a very weak correlation. I'm guessing it's yes, that it's not, I'm not just cynical and saying, oh, money doesn't make a good horror film, because my guess is that there are a lot of low budget movies that are kind of bad. And the highly watched movies, maybe they get some, marketing behind them. But I'm going to guess that's a very weak correlation, doesn't explain a lot of the variation. That's just the prediction. Let's find out. Budget explaining movie rating, geom point, and scale. We know we'll need scale x log 10 because of the roughly normal distribution. Oops, I was not looking for movie rating. I was looking for, review rating. Review rating. It's a funny graph trying to... zero correlation. Actually, it's a little hard to say that right away. I'm going to add I'm going to add a best fit regression. Yeah, it looks really like zero. In fact, the line might even be tilting a little down, but notice the uncertainty around it. Yeah, there's no trend, no relationship between budget and rating. I'm going to throw this on the same dollar scale. Okay, no relationship. All right, is there a relationship between, how about movie rating and review? So interesting that, I don't know. I guess it's not that crazy at all. All right. So what do we have? Movie rating and review. Let's end review rating. Yeah. What I need to do is say count movie rating. How many we got here? All right. I'm definitely going to lump some of them together and say movie rating is FCT lump. We love lump in my Tidy Tuesday screencasts because I'll say I want 1, 2, 3, 4, 5. Looks like there are kind of 5 categories. TVMA is a TV rating, so it looks like we're mixing in some TV here. And then everything else is other. There are that few PG-13 horror movies. That doesn't feel right to me. Maybe it's a kind of a strange data set. Huh. What? Cool. All right. So, but from IMDb by way of Kaggle. Okay. So, lump our movie ratings, and we say top 5. And now, if I count the movie ratings, there's an other category. All right. It's top 5 plus the NAs. I'll leave in PG-13. And I'm going to say, let's see how movie rating affects review rating. Can you guess the kind of plot? I'm like a box plot for this because it's comparing distributions. I need to remove this count. Let's cohort flip. Why not? And, you know, this is not going to be all that meaningful, but I'm still going to say take my movie rating and FCT reorder movie rating by review rating. Just so I can look a little, FCT reorder this by this. What am I missing here? Reorder movie rating by, it should be doing it by the median. Yeah, I'm getting something wrong here. It's not grouped. Sometimes that's a problem. If I pull movie rating, I get my levels, TVMA, other, and there's still TOR. Well, no, this is looks ordered, but they don't feel like they're ordered by, let me try not is NA. Oh, okay. My issue is I do FCT reorder NARM equals true. Feeling it was the, here we go. NARM equals true is important in FCT reorder. Yeah, I don't think there's a difference between these. Does anyone know what statistical test we could use to determine that? That's right, ANOVA. So I'm going to actually take this lumped movie rating. I want to know, is there any variation here more than we expect by chance? I'm going to analyze the variance, that's ANOVA, and ask if if there's more variation within groups than between groups. I'm also going to filter not is NA movie rated. Here are my groups, and I'm going to ask LM explain movie review rating by movie rating and put that into ANOVA. So it does turn out that there is more variation here based on this is called an F test. There is more variation in review rating explained by movie rating than we'd expect by chance. How much of the variation is explained by it? That's still very small. This is our sum of squares within the between. That's the variation between, variation within. Still most of the variation unexplained, but it's not by chance. It's good to know. So it looks like the best rated tend to be PG-13 R. the lowest rated are your TV movies. TV movies, lowest rated. Doesn't sound crazy to me. And you're not rated, you're unrated. Okay, so these are like the professional ones, the ones that are movies, not TV, and that get an MPAA rating, get a higher rating. Okay, that was some analysis of our categorical variables. I really want to do some text analysis. But first I'm going to take one more look at genres. I got one more question about the question I had is these genres. The genres are split out, you can see, into like piped, like this pipe space. Pipe space, it's a little, I'm not accustomed to that, but there's a function called separate rows in tidyr that's really handy for this. I want to separate the genres row separated by pipe space. And now, boom, I've just duplicated the data. So we actually can see in here this, well, it's a little hard to see here, but I'm actually going to display it, title, year, genres. What happened is we duplicated something like this movie to show across action, horror, sci-fi. We also know that, all right, so every movie is horror, so horror is kind of be our baseline. Now, what are our genres? Be some really rare ones, I imagine. Yeah, we're gonna want another FCT lump. I'm gonna rename it to genre while I'm at it and say FCT lump into genres into 5 groups. And I'm gonna say, let's look at the distribution of genre by review rating, geom box plot, remove the select. And were any of these a little better than others? Dramas, maybe. Drama, mystery, a little higher rated. This is our baseline, the horror, like everything, all the movies are in this horror group. It looks like the average mystery and drama and maybe comedy are a little higher. Again, most of the variation not explained. Okay, we learned some things about this. I want to do some text parsing. What am I going to do with the text parsing? Well, I'm going to take a look at our plot. Let's take the first 6 rows and pull plot. Are these descriptive? Frank Mozart. What is this? Oh man, how is the strangest thing? Yeah, okay, so I think I might want to remove the directed by and the with. That's like a director and your cast. I wonder if I can parse that out. So what I actually do is say plot equals string remove directed, and then we have, here we're going to do a non-greedy capture anything up to a dot and a space. I think that should remove the directed part. Oops, remove from plot. I think it'll remove yep, there we go. We removed up to the with, but I didn't remove the with sentence. So I'm actually going to remove that as well. Oh, I have a different way to do this that I actually like a little bit more. Does the director, do we have a column for director? No, we just have a column for cast. Okay, I am going to use separate. What I'm going to do is say this. I'm going to separate the plot into multiple columns. I'm going to separate into director, cast. We already have a cast, so I'm going to call it cast sentence, because that's the whole sentence, the with sentence, and then the plot. I'm also going to say extra equals merge, and sep is dot space. Extra merge means that there's going to be more than 3 sentences for most of these. And if I say extra merge, expected 3 pieces, missing pieces, fill is right, and that will handle this to say sometimes they won't have they don't have a directed by and a cast sentence. Okay, and why did I do that? Because now if I pull the plot, I always just get starting from this sentence. Okay. All right, so that lets me separate out the plot. Why did I do that? Well, because I want to do some text part mining. What do I use for text mining? You guessed it, the tidytext package. Tidytext is a package created by Julia Silgi and me, now maintained by Julia, and we have a book about it called our Text Mining with R, available wherever books are sold. So we can take our plot now and unnest tokens, the key step in parsing text the tidy way. I want to create words out of the plot column, and that ought to do it. And I'm going to call this horror movies unnested. Last thing I do is move this in case I wanted to do this elsewhere. I'm going to do this up in the data cleaning step. See, that's why I keep a separate data cleaning step. And now I'm unnesting the words in this data set. So count the words in our plot. Some very uninteresting words until I anti-join on our built-in stop words set by word. House, friends, life, family, night. Ooh, man, yeah. Haunted house. People go in horror movies go with their friends. Their life and family and night. Okay. What can I do with these words? Well, one of my favorite things to do is I'm going to aggregate by word and find what are the words that tend to appear in highly rated movies and words that tend to appear in low rated. So I'm going to start with group by word and then summarize the movies is N. I'm actually going to filter for only the reviewed ones. Filter, not is in a review rating. I'm also going to do my stop word removing. Stop words are words like A and B. I'm going to do it up in the horror movies unnested step. And then I say, here's my movies, and here's my average rating is mean of review rating. Right? And I am going to arrange by descending movies, the number of movies. And I also really never care if there aren't at least, at least 50 movies with the word. It's not going to be very meaningful. I can probably go all the way up to 100. Okay, so there are 40 words that appear in at least 100 movie plot synopses. What words tend to mark good, well-rated horror movies versus poorly reviewed horror movies? Let's find out. And what I'm going to do is say word by average. What do you think? Geom point? Yeah. Let me start with a geom point where I'm going to do average rating on the y-axis and then a word, so average rating on the x-axis, word on the y-axis, geom point, and throw in a mutate word equals FCT reorder. You've seen me do things like this before if you've watched these. It's a satisfying graph because right away we're going to get the sense of like, there does look like there is a distribution of movies. Ones with Mother and Life, Strange Woods, okay? Those tend to be in the better reviewed movies, and ones like Evil and Abandoned tend to be a little bit lower. I don't know what this is confounded with. It's not confounded with time because we're only looking at a 7-year span of movies. It could be combined with something like rating or the budget. We saw budget was not correlated with reviews. All right, now I'm also curious. Are these I don't know if these are. I promise I don't know if these are actually predictive. I have a few choices here. I'm gonna land on the one that I'm kind of into doing no matter what, which is we call Lasso regression. So we're gonna do. We've done this. I've done this in at least 2 previous, maybe 3 previous screencasts. I'm a big fan of Lasso regression for predicting movie rating based on review rating based on words. Other thing I'm going to note as part of this process is I want to throw into this average rating, but also average budget. I'm curious, are there words that tend to appear in expensive movies, in high budget movies versus low budget? Mean. One of the problems, though, I just realized is some of them don't, the ones that have a rating don't have a budget, vice versa. I'm going to skip this one. I think it's not quite worth looking at right now. I'd rather get on to the Lasso regression. Okay, so I start by looking at our horror movies unnested. Do we have any duplicate titles? Yes. Wow. That's a huge issue. There's 74 movie versions of this movie. Are they all the same? Let's find out. Filter title equals alarmed 2014 count plot. I thought we had a plot. Oh, this is the oh, silly me. I was looking at the horror movies unnested. Did you catch that? I did not catch that. Alarm just happened to be one of the longer titles, but it was duplicated. Okay, so some movies are duplicated. I'm gonna throw in a step here where in our cleaning step where I say distinct title dot keep all equals true. Maybe there are duplicates and I'm losing one of them. I'm not going to bother figuring out when they're duplicates, when there aren't. It's just not worth the effort. All right. So what I'm going to do is and now I've got a unique horror movie processed. Okay. I'm going to rerun my horror movie unnested. And now here are my steps. I'm going to say how many words are there? A few too many. I'm going to add count. That's a step that adds an n column with a number of words to each. Add count to word and then filter for only words that appear. Now I'm going to set a higher threshold. Say any word that appears at least 10 times is allowed in my data set. Now if I count word, I get about 1,000 words. 1,000 enough? I'm going to do at least 20. So only words that appear at least 20 times. A total of 500, about 500 words. Okay, why am I doing this? I'm going to be using the glmnet package to do a lasso regression. Again, I've done this before, but if it's your first time, let's walk through it. The first step in doing a lasso regression is I need to cast this to a sparse matrix. I need to say, I actually realized first I need to count the number, because a word can appear multiple times, title and word. And now I get this data set that says each title has one or more words associated with it. I'm going to cast this to a sparse matrix. I want every row to be a title, every column to be a word, and the values within it to be n. So this is called my movie word matrix, like a document term matrix that's specific to our analysis. It's a sparse matrix. I load the library matrix, otherwise sometimes sparse matrices are hard to work with. And new glmnet. And what we have is a total of 3,200 movies, 501 words. And we're going to see for those words, which of those predict a higher or lower rating, if any do at all. So, okay, I'm going to take my movie word matrix. I need to work with the row names of it. The row names of it are these titles. And I need to actually use the titles to pull out the ratings. So I'm going to take my horror movies ratings and index them on based on match the row names of my matrix. Match is a really handy base R function. Match the row names to horror movies title. Rating. So this is like my Y vector. It's my ratings. Oops. Review rating. So if I look at a histogram of Y, there's all my movie ratings. I really like how it's really very close to normally distributed. Some little funky stuff on the side, but that means I can use this as my as what I'm predicting. Okay, I have my X. I'm just gonna call it rating, not Y. And now I can do. I forgot I should show the environment as I go. I was meant to do that. All right, I'm going to use the glmnet package to predict Y from X. So I'm going to say glmnet predicting using my movie word matrix to predict my ratings. And to see if there are words in plots that can be used to predict that a movie has higher ratings. Take this pair and yeah, it's a linear. I'm going to do the cross-validation right away to come up with what we're going to learn as a lambda parameter. So cross-validated CVGLMnet. I'm going to call this my lasso model. Y is constant. Y does not look constant to me, but there's some movies that don't have a rating. All right, I'm going to filter not is NA rating, review rating. And now I removed my missing data. It's strange to me that it says it's constant. I don't see what that means. Okay, this Lasso regression model is going to try getting us a coefficient for each word. But first, what it's going to do is teach us. Actually, I'm thinking about how to do this. No, I'm going to start by looking at our tidied version of our actual model. This model has this object glmNetFit. It's a huge, messy Lasso object that is a little bit hard to work with until we use the broom package to tidy it. Library broom, tidy this fit. Now what we can see is that if we have our coefficients showing up here for changing values of lambda. Lambda is a penalty parameter. What does this mean? Well, we're predicting a couple thousand movies that have review ratings, and we're using 500 predictors. That means we're very likely to overfit, to find that certain words, just by giving them some coefficient, are going to help our predictions. Lasso regression is a penalized regression method. What that means is it tries, the higher lambda is, the less likely it is to allow any of these words to actually have a coefficient at all. In fact, when lambda is high, it can send all of our terms to 0. That's why when lambda is all the way as high as 0.11, we just have an intercept term. But then once we get lambda a little lower, terms like friends, evil, and college all pop up, having negative impacts on the plot. Especially college is really quite negative. So I can actually show a graph of this, which is a little bit fun to show. I'm going to pick a couple terms. I'm going to say, look at friends, evil, college, and I don't know, haunted is haunted in the data set. And then I'm going to plot, as lambda changes, how does our estimate of our coefficients for each of these terms change? And I'm going to do it as geom line with color equals term. Finally, we usually do scale x log 10 when we're looking with lambda. All right, what this shows is that the term college has a very, very negative, large negative coefficient as soon as lambda goes down by a little bit. And then it decays off a little bit, and more terms get added. Like haunted only gets added when lambda gets to a particular point and has a negative impact. We saw earlier that the term mother had a positive impact. Where does that pop up? Okay, well, mother starts being positive at this value of lambda. I know what you're wondering if you haven't seen Lasso regression before, which is how do we pick a lambda? I promise we're going to get to it. But this is how we can explore through tidying this model. We explore as lambda gets smaller, our terms get farther from 0. Sometimes I like to do a geom h line, y-intercept equals 0, LTY equals 2, throw in a dashed line to represent 0. All right, so this is a couple of our terms. We're showing a plot of it. Now, how do we, so if I picked a lambda, a very early lambda, let's take a look at this. If I picked this value of lambda in the second step, the only things I would say is to predict a rating, we start with 5.07. If there's the word college, we subtract 0.05. Word evil, we subtract 0.03. Friends, we subtract a very small amount. It's not a very actively predictive model. So how do we choose lambda? Well, here's a method for taking a look at our Lasso model. We plot the cross-validated Lasso model. What this shows is, as lambda gets smaller, our mean squared error decreases. But then if lambda, this is because we start gaining a little bit of predictive power. But then as the lambda keeps getting smaller and smaller, less penalized, it actually goes up higher until when you cross this point, you're actually worse than not. Your mean squared error, your distance between your predictions and your actual reviews is actually worse than if we'd not done any prediction at all, if we just used if we just use the intercept term. So this is a sign that if we used a linear model to predict a rating based on the words in our plots, we would have overfit tremendously. We would have fit up here, shows how many non-zero terms are included. We could have fit 460 words all getting these terms, and they would have ended up just being a much worse model when done in a cross-validation than no model at all. So that's how we learn how this works. We can actually say Lasso model has a lambda min. That's this point where our lambda is minimized. Ideally, we'd use lambda within one standard error of the minimum. That's here, but that would mean no model at all. I'm going to be a little aggressive and say we want lambda to be at this value, and that looks like kind of where we've minimized our mean squared error, and that's what we want to use in our tidied fit. We're going to filter for lambda is equal to Lasso model lambda min. Now we've got 57 non-zero terms, and we can actually plot them as a term estimate. I'm going to flip these. No, I'm not. I'm going to make it a geom call and a coward flip, and throw in a reorder. So say term equals FCT reorder term by estimate. I never want to include the intercept on these, so I'm going to say term is not equal to intercept. Much better. Okay. And what this shows is there are positive effects of some of these things like teachers, unexpected, suddenly, okay, and quickly is very negative, as is military, army, trapped, owner, evil, and so on. All right, so remember earlier we saw some of these terms. We were filtering back then for ones that occurred at least 100 times, I think we were doing, but now we're filtering only for those that occur at least 20 times. But these are our largest terms. And what I want to show is that if I picked a few of these, if I said quickly seek army, as well as teacher and unexpected, and let's throw in friends and evil like we saw before, we're going to see is that most of these terms, these terms kind of pop up. Some of these pop up a little bit later. That is for a smaller value of lambda. And if I throw in geom v line that we chose, the geom v line where the x-intercept is equal to Lasso model lambda 1 SE, that's what we're filtering for. I meant lambda min. Here it is. We can see like this is the slice of the model that we're pulling out with some of these terms. So seek quickly became a kind of a big highly negative factor. So we want things about an unexpected teacher, not things about an evil army that is seeking something. Sure. All right, that's some positive and negative effects. Again, these are really pretty small predictions. I wouldn't overly focus on them. It doesn't look like we can be very accurate, which I think makes a lot of sense. Okay, so all right. Yes. Let's check what time was. All right. So that was a Lasso model for predicting based on terms, on words in the plot. Prediction based on words in plot. Okay. I now wonder, should I do the same? Yes, I shall. Here's what I'm going to do. I am going to do the same thing for words, but I'm going to do it on genres and cast. I'm going to combine as many features as we can. I could even put in rating. Can I put in rating? Yes, I'm gonna be putting in rating. All right. So predicting. What can we use? What else? Predicting. What it says. Throwing everything into a linear model. Cast. Director. Cast. Genre. Rating. Plot. Words. What's nice about a linear model is it's very flexible. I'm going to be including all of these. And I think we did something a little bit similar with board games a while back. And I always really like Lasso regression. I like how interpretable the results and understandable the results are. So what I'm going to do is take my, I've got my horror movie words already. I'm going to look now at my horror movies and take a few things that are combined. I'm going to select genres and director and cast, not cast sentence. Oh, and I always need title. Okay, so my title, my genres, my director, my cast. All right. What I'm gonna do is a couple parsing first. First, I'm gonna say take my director and string remove from director the directed by. Now, if I count director sort equals true, who's directed the most horror movies? Oh man, none of these people have directed very many at all. Okay, I'm gonna. Should I just skip it? I don't know. Maybe I'll keep. Maybe I'll leave them in. All right, I have already gone to that work. But all right, that's something we learned about director. Now I'm gonna gather. I'm gonna actually say gather my everything but my title into my type and my value. Everything but title. And now I'm actually keeping my genres, stacking my genres, my title, my director, and my cast on top of each other, which means I can again separate rows, but I'm going to be on value. I'm going to be doing it based on the separation of a pipe and either a space or that either has a space or this question mark means the space is optional. I use that because I noticed that genres are connected by pipe space, cast only by pipes. Why do this? Because I can now count my type and my value together. The genres are going to be all the ones near the top. But beyond genres, we're probably going to see some actors that are in many things. Eric Roberts, is that Julia Roberts' brother, the actor? I think so. And Lance Henriksen, he was in Alien. Was he in that many horror movies in the last 5 years? I'm pretty sure Lance Henriksen was in Alien. And yeah, I don't recognize a lot of these people. And then, all right, Danny Trejo, favorite of director Robert Rodriguez. All right, I recognize very few of these people. All right, so then I have, and I want to know, are there, let's see, here we go. These are my features. Every one of these titles is a type and a feature, and I'm actually going to unite the type and the feature to be, this is my, I'm going to call my features. I'm going to say there's genres, horror, genres, action, and so on. I'm going to combine these, I combine these two together. And throw in a n equals 1. What am I doing throwing in n equals 1? You're going to see in a moment. These are my features that are not words. And now I can take my horror movies and nested, combine them in. Oh, I'm probably going to do filter not is NA review rating. And now I can take my horror movies unnested, throw in the filter not as NA, review rating. But now I'm going to select from this title, word, and n. I need to have first count. Actually, I don't need to select. I just need to count title and word. And now I know I have my title, word, n. And look at this. I bind rows onto this, features. And now I have combined, rename feature, word to feature. And paste in word. I'm treating words a little differently than I treat the rest of the features. Didn't have to be, but here's my word camera, word days, word film, word found. I'm going to use the separator of like a, yeah, I'm going to use this as a separator just because I'm a little bit tired of, sep equals this. Word camera, word days. So now I've got my, my separation. And I need to quickly say group, still in my add count earlier, but now I've got an n column on top. I'm actually going to do a group by feature and filter for all the features must have at least, I don't know, let's say at least 10 appearances, appear in at least 10 movies. That means very few directors will get included, but some actors will get included, and certainly a lot of genres will get included. This turned out to be slower than I expected, so I'm going to change my mind a little bit. I'm going to add count for feature. I know it was that much faster. And then say n. Man, I replaced it. When I did add count, it just replaced that n that I already had. You know, I don't want that n. I just want, I don't know. I'll just keep the it as a binary matrix. Sorry, I was getting a little confused there because I was keeping an n to mean like the number of times a word appeared. I'll just do presence absence. Works for me. And now I'll say the n's must have happen at least 20 times. And oh, I meant 10. All right, and now I cast sparse my feature and my title, and now I can say, just checking, did I do, oh gosh, oops, I made a huge mistake here. I used n, oh no, that was a really big mistake I made here, which is I kept, oh no, I had a count here, okay. There was not a mistake, sorry about that. Here I counted after the add count, which meant I generally had my ones here. I was really worried that I'd put n in all the values, but I hadn't. I did fine. Okay. Then I'm going to cast sparse feature by word, and this is my feature, nope, other way around, title and feature, and this is my movie feature matrix. Not to be confused like a feature motion picture, but or even a double feature science fiction picture show, but rather one of these features like a word or a genre or a cast member. Did I miss anything I could have used to predict it? Yeah, I missed rating. Yeah, I can just keep it. All right. What I'm going to do is I'm actually going to say when I did all my select title, genres, director, and cast, I'm going to include movie rating as well. And now among my feature types, I actually kept a few that were like movie rating. I'm going to filter for one feature, movie rating, NA or so on. And I don't love the NA, so I'm going to say, after I gather, I'm going to say not is NA value. That'll remove any cases that I'm missing data. So here's all my movie ratings. Now just for free, they come in the mix, and I can take my features, combine them with the movie ratings. Here's my dimensions of my matrix, my new 1000 feature matrix, and I can do my prediction on it. Okay, I'm going to use the same approach I did earlier. I'm going to take my review ratings, take my Lasso model, and we're all about predicting movie ratings. I'm going to take movie feature matrix, match it to these review ratings, and looking good, and take my feature Lasso model, and I'm going to take my movie word matrix, feature Lasso model, feature word matrix, feature movie feature matrix rating. This time there were 1,000 features to predict 3,000 movies. Still finished pretty fast. Okay, and yeah. All right, and now I'm gonna try the same approach to visualizing it that I did earlier. Well, first I actually want to see if I plot my Lasso model. It's probably going to be even. Ooh, look at that. There's even like here's one difference. No, remember before I was just using plot words, and it was like it barely had a dip at all. In fact, the dip was kind of beyond what we saw with our within one standard error of the minimum. But I've added a couple terms that we know are meaningful. One of them is movie rating, and we know that movie rating has an impact on rating. We saw with that in the ANOVA. And we also have guessing genre is one of the bigger ones. We're going to see how genre affects this. So this I think is going to be really fun. We're going to create that same plot. wonder if there should be some tool for it. Well, for now I copy paste. And I'm going to filter down for my feature lasso model. I'm going to use 1SE, that is this one, because I want to be a little more conservative now that I have the option to do so. This means it's within one standard error of the minimum mean squared error. It's a typical conservative metric to say there's some uncertainty in where exactly the minimum is. I'm going to lean on the add fewer terms, penalize more side. So lambda minimum term is not intercept, right? And I'm going to create the same kind of plot I did before. Still really at, oh, I did not do 1SC. Look at me, I didn't even change. I talked about it, but I didn't change it. Okay, what it turns out is that animated horror movies are way more popular, way higher rated, followed by drama, including so one thing is when you start adding these features, different words are going to pop up as being meaningful. Oh, I also changed the threshold to be just 10. Word NA shouldn't. Oh, that happened when okay, I hate that it popped up, but that happened when I did my unnest. When I did my unnesting of the words, I really need to say horror movies unnested. Filter not is NA word. And now if I rerun this chunk, just don't like seeing things like that. I feel better already. Eric Roberts is that who I'm thinking of? Yeah, Eric Roberts. He is not a good sign. And Sharknado and everything with all the many Jaws sequels, whatever. Shark was a bad term. People like animated crime drama, mystery musicals. People do not like shark movies or TVMA not rated. Okay, so these are some of our terms that we added. It hit me there are other things we can add. And something I like about this kind of flexible feature approach is that we can we can keep adding terms. One is language. And the language are also separated by these pipes, which means they will get parsed properly. So I'm going to add, and they're going to get, and the rare ones, the ones that appear in fewer than 10, are going to be filtered out. Am I also going to do release country? I think I am, but I'm also a little bit nervous about it. Why am I nervous about it? Because we already saw that that there was a Japanese movie that it said was released in Canada. So these might not be completely trustworthy. Still, I'm going to add it. I'm adding all these terms together. And for all of these are going to be treated as categorical. They're going to be spread out, one row for every, here to show that we've got all of our features right here, genres horror, genres action, and so on. And then we get our features, we get our ratings, we create our predictive linear model. And Kannada, what's Kannada? It's a language of southwestern India. So it must have happened in at least 10 movies. We must have had at least 10 movies, which is not surprising. So it's an Indian language, and we can see that it generally has well-rated horror movies. That could be for a lot. That could be for a lot of reasons. It could be good quality. Could be a thriving subculture. Could also be that only the better movies in the set got into this data set. All right, but we still see animation, drama, mystery. Shark, Eric Roberts, Germany. Those are some of the negative signals. Okay, I'm going to clean this graph up a little bit so that it can be our kind of release product. What I'm going to say is X is, I don't really need it. I'm going to say coefficient for predicting horror movie rating. What affects a horror movie rating? I'll say subtitle based on a Lasso regression to predict. I'm going to hard code this one just because I'd like to know. I'm going to hard code the number of movies we use to predict 30, 51, 3 is in case I change it later, 3,000 movies. IMDb ratings. Movie rating. IMDb ratings of, I like to have an informative subtitle. And notice all these flexible features that can affect things. I doubt that all put together, this is a particularly predictive model. Like if you do not have Shark, Eric Roberts, or Germany, if you're not from in the language Kannada or indie or animation, drama, mystery, crime, if you're not one of these genres, and most are not going to be, you don't have a lot that's going to affect your rating. Though English language looks like it is lower than others, and your rating affects it a little bit. Still, this is what we came up with as a predictive model of horror movie rating. I really like this approach. Let's see. Anything else I want to polish here? I could add a color. Don't have to. This is I think this is a pretty solid approach. Again, like at the end of the day, when you're predicting whether a movie is good, you're not going to just add up a couple cast members. Though I'm really impressed that a cast member popped up. I guess Eric Roberts is one of the more common ones, but you're not going to predict based on the cast. You're not going to maybe predict a little based on the genre. You're not just throwing the words into a blender. There's a lot more that goes into whether a movie is going to end up being well received by audiences or not. So this was a lot of fun, but there's reasons we don't expect this to be like an incredibly predictive model. But I'm glad I got to show some of how you can combine text mining and a few other approaches to show how to see how we can predict something like rating out of a data set. Okay, I'm gonna save my file, which I haven't done yet. What was this? This is horror movie ratings. And let's review what we learned. We did a little processing with extract and separate. We took a look at some things like budgets and even discovered that budgets and ratings are not correlated. Higher budget movies do not generally get higher ratings. And then we discovered that movie reviews do a bit, and that was important once we started doing a predictive model. And then the genres do as well. We can see that drama and mystery and kind of comedy do perform a little bit better. And with how we set off into our text mining and our predictive modeling and came up with this general this combined linear model for predicting the horror movie's ratings based on various features of the movie. All right, that was really fun. I still don't have an answer of what movie I should watch. Partly because the truth is, I think movie rating isn't necessarily what I'm going to make my choice on. I might make it based on what kind of movie, the kind of movie that I like. So what is my favorite horror movie? Some of my favorite horror movies include Cabin in the Woods, Get Out, and Scream. And one thing those all have in common with each is their comedies. So I actually really like horror movie comedies, and that means, what am I going to watch? Well, if I wanted to look at that, I didn't need to fit a predictive model. I didn't need to say, well, animation and in dramas or mysteries. I could have just said, let's take my horror movie data set, filter for ones that have genres, filter for the word comedy in the genre, arrange by descending review rating, and select our title, year, plot. Title, year, plot. Do I care about the director? Maybe. And throw in the budget and the language. And then I might take a look at some of these. The Carmilla movie. I think a lot of these that are... let me throw in the movie rating because maybe if I want, I also I don't really like amateur movies, so I'm going to say not is in a movie rating. And I'm going to say not is in a movie rating, not is in a movie budget. That should really kind of filter for my slightly more professional movies. All right. This list kind of works for me. I actually love What We Do in the Shadows. I forgot that on my list of horror comedies that I like. And I should include the review rating in here. I don't even really need the year. Most of them are very recent. I really like What We Do in the Shadows. I haven't heard of Only Lovers Left Alive. Looks like it's in a combination of languages. Hotel Transylvania and Frankenweenie are kids' movies. Maybe I should include. Was G a rating? Let me see. Movie. I'm not necessarily in the mood for a PG movie, so I could filter by that and say not as an A movie, not as an A budget, not rating. Oh, movie rating is not equal to PG. Cool. And now I learned things like I don't know. Some of these could be really fun. I'll take a look. I'll take a look at them, and then we get down into some of the worst ones. Some of the worst of the movies like zombies versus strippers. Sure. All right, but yeah, I think I should check out Only Lovers Left Alive. It seems like a highly rated horror comedy, which is my type of Halloween movie. All right. All right, so we did a predictive model, and then we did a little bit of exploration so that I could pick a movie to watch this month. And we saw that involves a lot more like looking through the data, a lot of filtering, a lot of sorting, and some critical thinking about my own preferences. But overall, all these kind of fit together into a data analysis. All right, that's it for today. I hope you had a lot of fun. I certainly did. I'll see you next time.